Okay, for today we look for the 2 power of n. Power of n is the number of variable. Okay, as you can see here, n is the number of variable, and then if p is 2 power of 0, q 2 power of 1, this one 2 power of 2. 2 power of 2 mean that they have a sequence 1, 2, 3, 4. Okay, and then p and q is 1 plus 1, and then plus 1 is 1, and then the other is true. Okay, okay, this one is okay, and then for p and q and r, we have 2 power of 0 is 1. This one I've explained. And then 2 power of 1 is equal to 2, and 2 power of 2 equals to 4. Okay, and then for this one, 2 power of 3, because they have 3 variable, 1, 2, and 3. And then for the truth table, you need to have 8, until 8. Okay, is it okay? Nabila, boleh ke? Intan? Intan boleh ke? Okay, okay, for this one, as you can see, the number 2 power of 0 is 1, 2 power of 1 is equal to 2, and 2 power of 2 is 4. Okay, and then we have here P and Q and R. The number is 8 because 2 power of 3 equivalent to 8. Okay, and then as you can see here, P, Q, R, true, false, true. P and Q, one n is multiply. 1 multiplied by 0 is 0, and so on. Okay, we have 0 multiplied by 1 is false. Okay, 0. Okay, 1 multiplied by 1 is equivalent to 1. Okay, here is we have 4. 4 variable here. 2 power of 4 equivalent to 16. Okay, they have 1 until 16. Okay, how to generate the truth table? First of all, you need to have for p is 2 power of 0. Okay, and then q 2 power of 1, 2 power of 2. Okay, and then we have here P and Q, and R, 2 power of 3 is equal to 8. And then we should have 8. 1, 2, 3, 4, 5, 6, 7, 8. Okay, this one is another example for the hypothesis. Normally for the hypothesis, we denote as H and conclusion as C. And then Maria learned discrete structure is hypothesis. And Maria will find a good job is the conclusion. That's why express the statement P implies Q, hypothesis implies the conclusion. Okay, if Maria learn the discrete structure, then she will find a good job. This one is first case. Okay, and then second one, the conclusion follows by hypothesis. Okay, okay, and then Maria learn discrete structure only if she will find a good job is a conclusion. IFF, if and only if. This one we have learned last few weeks. Okay, for this one we have a converse, inverse, and the other one we have contrapositive. This one is the mathematical converse, inverse, and contrapositive. Okay, let's say if the statement if P then Q, we can create three related statement lah. Okay. Example, I give you an example. Okay, if Q and P, if P then Q, sorry, if P then Q, if P then Q, we can create three related statement. A conditional consists of two parts, a hypothesis if clause and a conclusion in the then clause lah. Okay, if one statement, then Q is another statement lah. We have two lah. For instance, if it is rain, then they cancel the school lah. Okay, if it's rain, if it rains, then okay, if it's rain, then they cancel school. Okay, it's rain is the hypothesis. It's rain if it rain is the hypothesis H. Then they cancel the school is the conclusion. C. Conclusion. Okay, boleh ke? Fatin? Fatin boleh ke? Fatin Najiha? Okay. Okay, to form the converse, first one is the converse. Okay, open up another one. Okay, for the first one is the converse. Okay, to form the converse of conditional statement, interchange the hypothesis and the conclusion. We interchange the conclusion and the hypothesis. Okay, with the hypothesis and conclusion. Okay. Okay. So the statement. Okay, the statement. If it is rain, they cancel the school. If we converse, if they cancel the school, if they cancel the school, we just switch. If okay, this one for the if they cancel school, then it rain. Okay, this one for the converse. Okay, second one. What is second one? Inverse. Okay, so far do you have any question? Arina, okay. Anissa? Arina, boleh ke Hakimah? Nur Hakimah? Ni baru first time kau masuk saya punya ni, kelas. Sebelum ni masuk juga? Okay. Kamu sem berapa Oh, sem 1. Tu dah ada baby dah? Oh, ya kan nak gamu. Tu yang saya terkejut. Okay, for the converse, to form the for the inverse conditional statement, take the negation of both of the hypothesis and the conclusion. You need to do some operation here. You need to take the negation. Negation. So for the inverse, okay. If it does not rain, then they do not cancel the school. Okay, that one for the inverse. If it does not, then if it does not rain, okay, then they do not cancel school. Okay, for the inverse, take the negation. Negation for both. Okay, boleh Akmal? Oh, jangan marah saya. Kamu ada kelas ke sebelum ni? Penat ketika kelas. Okay, so okay, and the last one is to form the contrapositive. Contrapositive. Please be remember contrapositive. This one is the last form. Interchange the hypothesis and conclusion of the inverse statement. Interchange. Okay. Interchange the hypothesis and conclusion. Okay, you need to inverse first. Okay. Okay. If they do not cancel the school. Okay. If they do not cancel the school, then it does rain. Then it does rain. Okay, this one is the third one. Contrapositive interchange the hypothesis and the conclusion for the inverse statement. Okay, this one is just explanation. Inverse is conditional statement that is sitting not for the hypothesis. Before that is the converse. Converse is conditional statement that formed by switching the hypothesis and the conclusion. This one is another example. If I am sleeping, then I am breathing. Okay. For the converse, I am breathing, then I am sleeping. You okay? Hypothesis. This one hypothesis and the conclusion. This one conclusion and hypothesis. Okay. You just switch. Switch. Okay, for the inverse, conditional statement is formed by negating inserting not the hypothesis and the conclusion. I am breathing, then I am sleeping, then I am breathing. Okay, conditional is inserting negation. Not is also the negation. Negation. Okay, I am not sleeping, then I am not breathing. Okay, and then for the contrapositive, as I said, you need to form the negation for the hypothesis and the conclusion of the converse. For example, I am sleeping, then I am breathing. Okay, for the converse, I am breathing, then I am sleeping. Okay, you need to to change. I am breathing, then I am sleeping. Okay, for the conditional, for the contrapositive, I am not breathing, then I am sleeping. Okay, from here, contrapositive. Okay, this one for the conditional, inverse, converse, and contrapositive. Okay, for the conditional, inverse, converse, and contrapositive also. Okay, the conditional statement, inverse, converse, and contrapositive all have the truth value that we can determine if they are true or false. Please be remember conditional statement. Okay, they have three, one, two, and three. All of them have the true value. And then when two statements are both true or both false, we can say that they are logically equivalent. Logically equivalent. Okay, logically equivalent meaning that two expressions are logically equivalent provided that they have the same truth value for all possible combination. Combination later on you have to do in the truth table. Okay, for all variable appearing in the two expression, basically we are comparing two expression. In this case, we can write x is equivalent to y and say that x are logically equivalent. Okay, we can say x is equivalent to y, and that we can say that x and y are logically equivalent. Okay, for this one, for the practice, please upload this one in the Padlet. Padlet, you need to uh, to write down your own notes in the Padlet. Please upload by tonight. I think by tonight is okay. Good. Okay. Because in the same time when you heard me conveying the notes, you can also take the simple notes. Okay, this one I have explained. Okay, same goes to here. Underline the portion of the conditional statement. If the weather is warm, then we should go swimming. Okay, please do either A, B, C, and then please give the reason. Reason. Okay. Okay, same goes to identify the underlying portion. Okay, identify the converse. This one is not meant for the assignment, just for your own practices. No? Okay, logically equivalent. Okay, I have explained to you. We have a proposition here, a negate P and negate Q. Okay, we have a negate P and Q. Question, are both compound proposition are logically equivalent? First of all, you need to do is you need to have the truth table. Okay, P, Q, okay, 2 power of 0, 2 power of 1, and then you have to negate P and negate Q. Okay, uh, and then after that, you have to have the implication, implication, negate P or negate Q, and then this one is the output. And then after that, you have to do the second proposition, negate before that you have to P and Q and then negate P and Q, and then for both here they are logically equivalent, all are true value for these two proposition are same for the output. Okay, false and false, true and true, true and true, true and true. Both column have the same truth values. They are logically equivalent. uh, the other name is we call it as tautology. Tautology. Okay. Tautology. What is tautology? Tautology is in mathematics. Tautology is a formula or assertion that is true in every possible interpretation. Interpretation here we have two interpretation or two proposition that we compound logically. For first one is negate P or negate Q, and the second one is negate a P and Q. Okay, therefore, both columns have the same value. Therefore, they are logically equivalent, and we name it as a tautology. Okay, for example, we can say also for the tautology, x equals to y and x is not equal to y. Okay. Similarly, to go to the either the ball is green or the ball is not green is always true. Okay, this one is always true. Okay, that we call it as tautology. Okay, this one is statement and operator. Statement and operator can be combined together in the way that they form a new statement. For this one, okay, 2 power of 0, 2 power of 1. Okay, and then we have negate P and negate Q. Both have the false values, false, false and false, true, and so on. Okay, same goes here. Negate P on negate Q. Okay, first of all, you need to do the truth table first. Okay, you need to form this one first. Secondly, okay, then you negate both of the expression, and then after that you combine with the or operator. Okay, this one same true false, true true, false false, and so on. Okay, same goes here. Statement and operation. Statement and operator can be combined in a way to form a new segment. Okay, for this one, we have here the values. All the values are the same. One, proposition one and proposition two, the output are the same. Therefore, it is a tautology because we have a truth value. True, 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 true. Okay. All the output of the proposition 1 and 2 are true, are true. And then first is must be the same. Okay, this one the output for every proposition are same. And then we you go by the by conditional. Okay, this one is true, 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 true. Okay, if the requirement is fulfilled, then it is a tautology. Okay, and then here we have a logically equivalent. Also same if you have a negation and negative x, we can have x because negative and negative to be a positive. Okay, and then for the positive values, we do not write the positive values. Okay, and then tautology, all the values are true. Okay, this one I have discussed. Okay, secondly, all the values are false is the contradiction. Okay, contradiction. I have explained how to contradict. Okay, contradiction in logic is when a proposition conflict either with itself or established fact. For example, is contradict from tautology. Contradict from tautology is a false. And then we have contingency. Contingency. Okay, for the contingency truth table. Contingency for the truth table. If the proposition is true in every row of the table, it is a tautology. And then since it's true in the last one row and false in the last one row, it is a contingency. Okay, like this. Okay, this one is tautology. If you find for the all uh, okay. Okay, for example, this one, if you find this one false, let's say this one is false. Okay, let's say this one is false. Okay, this one is a contingency. You want only one row. False, you can name it as a contingency. Okay, they have one. They have one row. and false in at least one row, it is a contingency. Is it okay? Anish, okay ke Anish? Okay, this one is combination of true and false, or either one. Okay, combination true and false. Okay, let's say in the truth table you have false, true, true, true. Okay, this one is contingency. Okay, if you find all the truth value true, 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 it is a tautology. Okay, please do this exercise. Okay, in the Padlet. Okay, exercise determine the true value of following operation. 1 and 2 are they logically equivalent. Okay, and you have to write down in this table. Okay, so far do you have any question? Intan boleh ke? Okay, go to the other slide. Okay. Okay, this one is basic terminology. This one I have explained is a proposition which is always true. Okay, for example, we have P or negate P, one variable. Okay, we have 2 power of 1 is equal to 2 lah. Okay, and then contradict is proposition that is always false. We have this one is true. This one is false. True and false. And then contingency is proposition that neither a tautology nor a contradiction. This one is neither one. Okay, for example, P or Q if you imply the negate R. This one contingency for the contingency. Okay, for example, you find one for the false, let's say like this. Only one row is false, then it is a contingency. Okay, for example, here we have P or negate P is one variable. Okay, always true is tautology, always false is contradiction. Okay, if you find let's say this one false, this one true, it is called contingency. Okay, and then logical equivalences. It is two propositions that you compound. Okay, they have the same truth value in all possible cases. And then two propositions that are equally and logically equivalent if P is biconditional, Q is tautology. Okay, all the output is true. True. Okay, this one you can use equivalent. Either you use this one or you can use three lines. P is equivalent to Q is equivalent. Okay, determining the logical equivalent. First, you need to use the truth table. Secondly, show the uh, proposition 1 and 2 are logically equivalent in the truth table. Okay, not every not a very efficient method. Why? Hakimah ada ni ke? Ada reason ke kenapa dia tak efficient? Syafika? Okay, it is not efficient method because you have to do all of this repeatedly. And then solution develop a series of equivalences. This one seems more likely as a syntax. Syntax in maths, logical math. Okay, we have identity, we have domination, idempotent, and double negation. This one is 3, 4. We have 4 important equivalence. Okay. Identity equivalences. Okay, for example, we have P and true. It is a proportional equivalences, and then Q and T are equal to Q. This one we name it as identity. Okay, compare the equation 1 and compare with the equation 2. Okay, we can call uh, for the multiplicative identity for logical operator, the identity for disjunction. Okay, disjunction we have true. Okay, for here we have disjunction. Okay, false, and the identity for the conjunction is true. Okay, this one is for the identity, and then the second one is we have domination. Compared to the equation, compared to the equation, x multiplied by 0 is 0 for real number. The result is always 0 regardless of the value x. And then the 0 for the disjunction t and 0 for the conjunction is f. It must be false. Okay, this one is domination. Okay, for the idempotent, when an operation is applied to a pair of identical logical statement, okay, we can find here is logical p is we have is equivalent to p. Okay, this one is for the uh, idempotent. Idempotent. Okay, the result is same with the logical statement. Compare for the equation. We have a p or p is equivalent to p and p is equivalent to p. This one idempotent. And then we have a double negation. Double negation, which means that you negate 2 times. 2 times, for example, we have negation, negate, negate, and for negative x. And then we have negative x because negative multiplied by negative is positive, and positive multiplied by the negative is equivalent to negative. Is it okay for identity, domination, idempotent, and double negation? Is it okay? Okay, and then we have another 4. Total together is 8. This one is number 5, number 6, number 7, and number 8. Okay, we have commutative property. In short, uh, uh, they will conclude for the commutative is the order of operation does not matter. Does not matter. Okay, for the commutative, it doesn't matter which of the two logical statements come first, and the result from the conjunction and disjunction always produce the same truth value. For example, here we have P disjunction, disjunction, and okay, the other one we have the uh, conjunction and disjunction. This one is conjunction and disjunction. Okay, both produce the same output. Okay, this one is commutative. And then for the second one is the associative. Is roughly speaking, for this property also say that the order of operation is does not matter. However, there is a key difference between them and commutative properties. Okay, for the associative is different from the commutative. Commutative property apply to operation on the two logical statement, but associative involves three logical statement. Okay, since disjunction and conjunction are binary operation, we can only work on a pair of statement at a time. Okay, and the important consequences of the associative property is since it does not matter on the which pair of the statement we should carry out the operation first, we can eliminate the parentheses. Okay, for the associative, we need to eliminate the parentheses. Okay, eliminate the parentheses. Okay, and then after that, uh, we have the distributive law. Distributive law means when we mix two different operations on the three logical statements. One of them has worked on a pair of statements first, forming an inner operation, then followed by the outer operation. Okay, P is the outer. Okay, and then we go by the inner operation Q and R. Okay, this one for the distributive. P and Q or R, this one is outer. We do the inner first, then we go by the outer. Okay, and then this one is for the distributive. And then for the De Morgan law, when we negate disjunction, okay, respectively conjunction, and we have to negate the two logical operator. We have to negate. We have to negate a two logical statement and change the operation from disjunction to disjunction. So we change the operation. Here we change the operation. Okay. Here, for example, we have negative x plus y. We can have negative x, negative y lah. Okay. Anis okay Anis? Anis diam je. Faham tak ni? Okay. Yang faham je nanti exam nanti kamu tengah-tengah kata saya tak terangkan pula. Okay, this one is identity and domination. Identity and domination. For this one, identity and domination. Okay, for the identity. Okay, for the identity, you compare the two equation. Compare for the two equation here. We have P and and true is equivalent to P and P of false equivalent to false. Okay, okay, the compare of the equation is unchanged after multiplying by 1. Okay, and then we can call the number 1 the multiplicative identity. For logical operation, identity for disjunction is F, false, and the identity for conjunction is true. Conjunction P is true, and disjunction for P is false. This one for identity. And then for the domination, compare the two equation. Okay, to compare for the two equation, the result is always 0. Okay, regardless of the value. Okay, the 0 for the disjunction is true. Okay, and 0 for conjunction is false. Okay, conjunction, you can have this one. Okay, this one is differently for this one. This one is disjunction. This one is conjunction. Okay, And then for the conjunction, for the domination law must be false. Okay, for disjunction, for identity is false, but reverse, you can reverse the identity and domination. Okay, bear in mind that for logical operation, the identity for disjunction is false, and the identity for conjunction is true. This one conjunction true. This one disjunction. Sesuatu boleh ke? Ha? Oh, link tak dapat masuk, mungkin internet kot. Tolong respon Saya tengah mengajar. Okay, and then we have absorption and negation. Absorption and negation. Okay, absorption law with the negation ni boleh masuk, udah ni boleh masuk dah. Tadi tak boleh masuk tak apa, nanti tengok ni Tengok apa tu? Tengok YouTube, nanti saya akan upload kat YouTube, jangan risau. Okay, absorption is a valid argument form and rule of inference of propositional logic. The rule state if P implies Q, then P implies P and Q. The rules make it possible to introduce the conjunction to prove. Okay, and then it's called the law of absorption because the term Q is absorbed by the term P. The term Q is absorbed by the term P in consequence. Okay, for example, here we can have same P. Here same P and P. Okay, for disjunction, for the conjunction P and P same. Here is the same. And then for the equivalences, you can find this one also same. Okay, for the negation, we have P and negate P equivalent to true. Okay, P and negate P equivalent to false. This one is negation. You negate. Okay. Negation is the rule of inference or transformation rule in the field of propositional calculus. Negation introduces state if the antecedent implies both of the consequences and it complement, then the antecedent is a contradiction. Contradict. Okay. Okay. If P or negate P implies true, and then we have P this conjunction and negate P are false. Okay, and then we have a distributive law. Okay, distributive law. Distributive law, when we mix two different operations. Sekejap Waalaikumsalam. Ya saya. Belum. Boleh. Saya tunggulah. Okey, nanti saya WhatsApp kat tuan. Ya, sama. Salam. Okay, distributive law. Again, when we mix two different operation on three logical statement, okay, one of them has to work on a pair of statement first, forming the inner operation. This one I have explained. For example, we have P or Q and R. Okay, this is followed by the outer operation to complete the compound statement. Distributive law says that we can distribute the outer operation over the inner one. Okay, we have distributive is equivalent to P or Q and P or R. Okay, this one is equivalent for distributive. Okay, distributive, bear in mind when you want to mix three logical statements, one of them has to work in the outer and for the inner. This one outer, and then we have inner. This one, okay, inner and outer lah. Okay, but the output is same. Same. This one is distributive law. Okay, and then we have De Morgan law. Okay, De Morgan law, when we negate a disjunction, okay, respectively a conjunction. Conjunction is and. Okay, we have to negate the two logical statement and change the operation from disjunction to conjunction. We have to we have to change. We have to change the disjunction and conjunction. For example, we have negate P or Q is equivalent to negate P and negate Q. Okay, and then here P or negate Q is equivalent to negate P and Q. Here we change. Okay, for example, this one I have explained to you. Negative x plus 1, uh, we must complete the outer statement, outer operation of the statement, negative x and negative y. And then negate P and Q. Okay, uh, okay, this one conjunction should be disjunction. And then P and negate Q, we negate we negate P, negate P and Q okay, and then we just change the position here to go here. Okay, okay, this one is another De Morgan law. Okay, De Morgan law stated that when we negate a disjunction, okay, or respectively a conjunction, conjunction and, okay, we have to negate the two logical statement and change the operation from disjunction to conjunction. And then respectively, when you have the conjunction, you need to negate to disjunction. Okay. Okay. Bear in mind, you need to negate either disjunction or conjunction. Okay, this one is conjunction. The other one is disjunction or front end. Okay, this one distributed and absorption. Okay, absorption and distributive I explained to you. Okay, again for the absorption is a valid argument form and rule of inferences of propositional logic. Okay, the the law of absorption because of the term repeated. Okay, repeated. For example, P or P and Q. and then the term uh, Q is absorbed by P. Okay, the term of Q is absorbed by P. Okay, we have a repeated variable. Okay, P and P. Okay, and then for the distributive. Okay, for the distributive, when we mix two different operation, okay, we have the inner operation and outer operation. Okay, and then P or Q and R, we have P or Q and P or R. Okay, is it okay? Okay, same goes here. We have domination. Okay, we here we can call it as a tautology, and then we have a commutative, negation, and domination. Name of equivalences. Okay, again, I explain what is commutative. Commutative is, in short, we can say the order of operation does not matter. It does not matter which the two logical statement come first. That one is commutative. Okay, and then for the negation, for the negation again, okay, you should know for the negation is a rule of inference of transformation rule. Okay, that give the antecedent implies both of consequent and complement. Then antecedent is a contradiction. Okay, again for the domination, compare the two equation. Uh, Regardless of the value, the output of disjunction is true, and for the conjunction is false. This one is domination. Compare to the sum equation. Okay, this one is equivalences. We have three: commutative, negation, and domination. This one is the three types. One, two, and three. Okay, this one again. When you see all of the truth value, we name it as a tautology. Okay, if one of them false, we name it as a contingency. Contingency. Okay. Okay, we have implication equivalences. Okay, we have hypothesis and conclusion, and hypothesis and conclusion. Okay, if we have a hypothesis implies the conclusion is same or equivalences to we negate the hypothesis and or this one or the conclusion. So this one is in implication equivalences. Okay, same goes to the conditional statement and contrapositive. Contrapositive. Okay, we have the conditional statement. Okay, P implies Q and P implies R is equivalent to P implies Q and R. Okay. Okay. Contrapositive. I have explained to you what is contrapositive. You need to inverse first. Okay. Contrapositive a proposition theorem formed by contradict. Okay. The both subject and predicate or both hypothesis and conclusion of given proposition. And then interchanging the theorem and for example, if not B, then not A. Okay, for the contrapositive, if A, then B. Okay, and then we have a biconditional. Biconditional, you must use the conjunction, not disjunction or is prohibited. This one, bear in mind, or is prohibited for the for biconditional. Biconditional. You must conjunctive. Okay, and then again, I explain to you inverse, converse, and contrapositive. What is inverse? Inverse, last slide I have explained to you what is inverse. And then we have converse and contrapositive. Again, for the inverse, we have converse, and then we have contrapositive. Okay, for the inverse, converse, inverse, and contrapositive. Okay, for the converse, interchange the hypothesis and conclusion. Uh, for the converse, you interchange the hypothesis and conclusion. For the inverse, you negate the both hypothesis and conclusion. For the contrapositive, okay, you interchange the hypothesis and the conclusion of the inverse statement. Okay, we negate hypothesis or conclusion and maintain. Okay, this one conditional statement. For two converse, for the contrapositive, okay, you change the position. Okay, conclusion. This one is hypothesis lah. You have to negate negate both lah. Okay, this one conditional statement. We have a contrapositive. Okay, and then here and here. Okay, 2 power of 2 because we have a 2 variable here is 4 lah. 1, 2, 3, 4. Okay, for the exercise, okay, left and right. Okay, the answer we have left and right are logically equivalent. For left and right, okay, first we have to do is implication, secondly equivalence, thirdly De Morgan law, and fourthly negation. For negate P implies Q. Okay, and then for the right to left, okay, we have first De Morgan law, second implication, third equivalent, and fourth double negation. For the fourth process is same. Okay, and then for the implication, okay, we have hypothesis and conclusion. Okay, for the here we just put the negation for the outer to the inner, and then negate P, and then we have double negation P and Q is same to the negation P implies Q. Okay, this one is same for this one. This one is same for this one. Boleh? As Asmaniza okay? Iza okay? Haris okay ke Haris? Okay, this one is just to show that they are logically equivalent. Maksudnya sama. Sama. Maksudnya kalau macam ni dia ada proses ni, proses 1, 2, 3, 4 ni. Kalau dia left to right, okay, daripada kiri ke kanan, okay, kita akan gunakan implication equivalent De Morgan dengan double negation. Okay, kalau kita buat daripada kanan ke kiri, kita buat De Morgan dulu, implication equivalent and double negation. Jadi the final output is same. Okay, same. Dia punya question dia macam ni lah. Okay. show that P and Q are equivalent to P or Q. Okay. Okay. This one is complement. It's easier. Okay. Okay. This one is you need to prove is this is tautology. Tautology. For this one, P and Q implies P or Q is true. It's true. And then from left here to right. Okay. We have a hypothesis here, and then we have conclusion here. Okay. For first one, we have to implication equivalence. Implication equivalent. You have to negate P and Q, or this one, disjunction P or Q lah. And then De Morgan law, negate P or negate Q. This one same, P and Q. And then you have to do is commutative. Negate P or negate P. This one or lah, or negate Q or Q lah. And then for the true, because you have the negation, true versus true is true lah. Okay, this one for the disjunction. Okay, my computer hanging. Okay, never mind. I think on a Friday evening. Do you have classes on Friday evening? Pukul berapa? Kita buat kelas jam pukul 5 sampai pukul 7 boleh? Kita buat kelas pukul 5 sampai pukul 7 boleh ke? Boleh. Sebab okay, this one is true. The answer is proven. Okay, this one also proven. And then for predicate and quantifier, we continue on Friday evening because Friday morning I have a program.